So then we moved on, and once we'd done that, and then we kind of came back to the syllabus, and we blitzed through it. And one of the things was trigonometry, and we did just some basic trig. And then I said, right, I want you to measure the height of that tree out the front. So they estimated it, they went around the school asking people what they thought it was, and then they had to come up with how to actually measure it. And I didn't give them anything, I just literally said, measure it. And they failed, you know, it was unscaffolded, it was a good group task because they had to kind of use ingenuity and creativity. It's actually quite different from doing a question in the book. I didn't realise how difficult it was to actually measure a tree, because just finding the angle without being given an inclinometer or a sextant or anything is quite tricky. So they just grabbed my board protractor, and they went to the DT workshop and got a piece of tubing, which they thought was quite a good way of doing it. And then they measured different distances away from the tree, and they got a variety of measurements. Then they did the trigonometry, and then they averaged their results. It turns out that the tree was actually 50 meters, and no one thought it was that high, so that was quite interesting for them. There was no spoon feeding. It involved a lot of group work and a lot of peer teaching and learning, which I thought was pretty cool. And then we published an article in the school newsletter about it. So again, it gave them a sense of self-esteem. It was something no one else had done, and they got to go outside and walk around a bit. So another example. Here's another example of the same class, what we did. They were going on an Outward Bound camp at the end of the year, and so I thought it was an ideal opportunity to get them to do some construction and also learn about the Southern Cross and navigation. So those of you who don't know, the way to find south, you basically draw a line through the long diagonal of the Southern Cross, and you find the pointer stars, and you draw a perpendicular bisector through the pointer stars, and where those two lines meet, you drop a perpendicular to the horizontal. And I created this in Algebra, and I had a solution sheet, and I did 3 different versions, and then basically that's south. They got to actually practice their construction. It gave them a really a good incentive to be as accurate as possible, because I held it up to the light, and if they were bang on, I gave them some kind of, I don't know, doggy stamp or some reward which was worth something. I'll talk a little bit more about rewards at the end of this talk, because that's something I'm very passionate about, school-wide rewards for effort, which actually work just as well as cash and chocolates. So this is for no particular reason, I just think it's brilliant. Those of you who haven't seen it, I'll play it to you. It shows how infuriating teaching can be.
It's from YouTube, so you can
Okay, here's your homework. First let me tell you the directions. What form take away 5? 1, 2, 3, 4, 5, 6. Take away. What's 6 take away 1? 1. No, you take away, so you take away 1 out of 6. How much does it equal? What's 10 minus 1? I don't know. 1, 2, 3, 4, 5, 6. 6, 7, 8, 9, 10. Nope. Take away 1. What is this? 1, 2, 3, 4, 5, 6, 7. Nope. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 1 more. And add 1 more. How many is equal? 1, 2, 3, 4, 5, 6, 7, 8. 1 equals 8 makes 9. See how you take away? You take away 1 and it equals 1. Do you get it now? Yes.
Isn't that your worst nightmare? I think that's brilliant. It's nice that it uses kids' voices as well, and there's a whole series of those. But you know, we do need infinite patience to be teachers, and you have to go through concepts again and again and again and again. Reinforcement. I mean, that's how learning takes place. You hear teachers in the common room sort of saying, I told them 3 times and they still don't get it. Well, tell them a 4th time or a 5th time. I mean, obviously. If I were to teach you guys how to say the numbers in Thai from 1 to 10, then song, sam, si, ha, hot, jet, pet, cow, si. Okay, can you remember that? You know it? Yeah? Shall I do it again? Do you think you'll remember it then? How many times would I have to do it? Well, clearly quite a few, because it's a new concept. So don't be afraid. Don't think you're a bad teacher because they don't get it, because it just means they need reinforcement. I kind of liken, and I tell my kids this, I sort of start usually in a new topic and I just teach the whole topic in one lesson. Big, holistic, you know, no pens, just like let's have an exploration of the topic, and then the next lesson I start from the beginning, or maybe I start somewhere else, and I'm constantly doing this. It's almost like sort of polishing a table. I'm coming back and going forward, coming back, going forward. So I'm going beyond what we need to do, and I'm coming back and revisiting concepts, and I tell them that so that they understand my crazy methods, and that they're not worried about it, and that they will come back to it. Anyway, here are some other... Oh, sorry, we've seen that. A colleague of mine said, had a bottom set. I don't like the word bottom set, but you understand what I mean. Unconfident low ability or whatever. Year 7 class, and trying to introduce algebra. And, you know, that's a pretty difficult concept. So I thought of an idea. I haven't actually tried this, but he said it worked really well, which was using these kind of unit blocks. And he just kind of chucked a whole load together and gave each of them some kind of shape thing, solid, made with these things. And he asked them to basically say how many yellow blocks there were, how many green blocks, how many blue blocks, and so on. And to represent that in some way. And so, you know, they started writing down so many green, so many blue. And some of them, you know, immediately started writing down 3G, 5B, 7Y, and so on. And then basically he found instinctively they were taking the solid apart. They said, can I take it apart? He said, you can do what you like with it. So they're taking it apart and sticking it back together with all the yellows together and all the greens together. And how great is that? Because it's something actually they can touch and feel, and then representing it as letters instead of like writing out green and yellow was actually a relief to them. You know, they didn't have to do all that writing. So that was a great way of symbolic representation of algebra. It's all about building confidence in years 7 and 8, particularly in those sets. I have a very strong belief that we shouldn't be assessing and testing kids in years 7 and 8 to be getting anything less than 60%. I mean, if it was up to me, I'd give them 50% for writing their name correctly. I think that we need to give them some very, very basic questions as being at least half the exam, so that they have a chance to actually show that they know something and they don't get smashed with their confidence, because once you put that light out, it's very, very hard to get it started again. So year 7 and 8, I believe, is all about nurture. So here's a livening up trigonometry a bit. Yeah. Get it? Okay. So I've just been teaching some trigonometry to year 11 again, and I'll show you some of the things I've sort of put in to just try and liven it up a bit and make it more of a real topic. This is the most wonderful applet. And there are others like it. I use this with extension to mechanics. But how good is this? It just shows you the link. Oh, why is that not working? Oh, hang on. Sorry. No. Okay, this is one of the problems with having the extended screen. I can see something nice here. You can't. Let's try this. Okay, now I can see that. There we go. So this shows the link between circular motion, simple harmonic motion, and sinusoid. And it also shows you that basically simple harmonic motion can be represented by any sinusoid, by a cosine, a cosine, or a sine function. It's just pretty nice, isn't it? It shows how trigonometry beyond 90 degrees can be found in all aspects of nature.